Now, you are welcome to the part 2 of this class where we are learning about connections in either series or parallel. And we have started with series and then we went on to talk about parallel. So let's continue on identifying things in parallel. Now, in the previous class, in part 1 of this video, I stated that to know whether two things are in parallel, the same voltage need to be across them. But one thing is that sometimes it's very difficult to see with your eye whether the same voltage is across two elements. So what you do is that you are going to go around the two elements, and if you don't find any other element, then you can conclude that they are in parallel. So if you watch the previous video to understand how to know two things are in parallel. So let's continue from here. Let's say I have a circuit like this. Let me take this one off here so that it become interesting. 2, 4, 6, 8, 10, 3. Let's say this is 18 volts. Now, if I want to identify whether two things are in parallel, as I said in the previous video, basic thing is to go around the two elements. If I don't meet any other element, then they are in parallel. Now, let's check if these 8 and 10 are in parallel. If I go around them, I don't meet any other element, they are in parallel. So 8 is in parallel with 10. Now, let's look at this 3 and this 8, whether they are in parallel. If I try going around, I come and meet an element on the way. So 3 and 8 are not in parallel. Now, let's look at this 6 and this 8, whether they are in parallel. If I go through this 6 and come through this 8 and come back, I don't meet any other element. So 6 and 8 are in parallel. Now, let's look at this 6 and this 10, whether they are in parallel. If I go through this 6 and pass through this 10 and come back, I don't see any other element. So the 6 and the 10 are also in parallel. Now, it would have been very difficult for you to use your eye to know that the same voltage across this 6 and 10, the voltage across this 6 and 10 are the same. With your eye like that, you may not really see because voltage is across. It's current that is true that you can easily see with your eye, right? So just go around the two elements like 6 and 8, 6 and 10 as we just did, and we realized that they were in parallel. Now let's check this 4 and this 6. Realize that if I try to go around them, I meet 2 on the way. So 4 and 6, they are not in parallel. They are not in parallel. You know, most students feel that when the resistors are standing, then they will be in parallel. Just because, you see, we started with a basic understanding like this, and they feel it's about the resistors standing. These 2 and 3 are in parallel. It's not about this standing. It's about whether when you go around them, you don't see any other element. So this is just the basic way to understand whether two things are in parallel or not. Now, one thing is that, let's see something like this. Let's say you have a circuit like this. And you want to know which of them are in parallel. Let's look at these 2 and 6, whether they are in parallel. If I go around, I meet an element on the way. 2 and 6 are not in parallel. 2 and 3, if I go around, I meet an element on the way. 2 and 3 are also not in parallel. But let's look at 3 and 6. If I go around 3 through to 6 and come back, you realize that I don't meet any other element. Then I can conclude that they are in parallel. Now, let's continue with our understanding. Now, let's say if you have a circuit like this, and you want to know which ones are in parallel, most of the time, when you try to identify whether things are in parallel in the middle of circuits, most of the time you find it difficult identifying whether they are in parallel or not. Now let's check 5 and 2 whether they are in parallel. If I go through this 5, I'll meet 4 on the way. So they are not in parallel. The fact that they are standing doesn't mean they are in parallel. Let's look at this 8 and 5. If I go through 8 and 5, it's not about passing through 8 and getting to 5. You should go around and come back. On your way, you find an element on the way. So they are not in parallel, right? So most of the time, finding parallel things in the middle of circuits sometimes will lead to nothing. So most of the time, you start from the ends of the circuit. Let's say from this end. Now from this end, let's check this 3 and 2. As you go around, you realize that they are in parallel. 2 and 3 are in parallel. So this is just the basic way to understand whether things are in parallel or they are not in parallel. And sometimes maybe the circuit extends to something like this. And same way, if you try to check if 20 and 18 are in parallel, go around, you pass an element, they are not in parallel. By checking 40 and 20, you realize that they are in parallel. So starting from the ends of the circuit, it's mostly easier to start identifying things in parallel or not. So this is just the basic way of understanding whether two things are in parallel or not. Now, what happens when two things are in parallel? Let's look at this simple parallel circuit. Now, if this is 2 and this 3, now we have concluded and gotten to know that when I go through this 2 and this 3, I will not pass through any other element. So 2 and 3 are in parallel. And when they are in parallel, what you do is, basically, if you had a circuit like this, and this was R1, and this was R2, then if they are in parallel, we all know that you find 1 over RT, the total resistance will be 1 over R1 plus 1 over R2. But most of the time, I don't like doing 1 over this plus 1 over this because sometimes you forget to find the reciprocal to find the total resistance. So here, if you could make RT the subject, you realize that you get R1, R2 over R1 plus R2. So I like using this. I'll just multiply the two resistors divided by their sum. And it's the same as using this formula. Now realize that the criteria I gave you to identify whether two things are in parallel deals with only two things at a time. Don't look at three things, right? Let's say somebody say, I'm checking whether 4, 3, and 2 are in parallel. You don't do that. You use only two elements because it's just a simple way to get to know whether the same voltage is across them. And it works with only two elements at a go. Good. So now we have realized that when two things are in parallel, we are going to multiply them divided by their addition. I can see 2 and 3 are in the parallel. So I'll say that their total resistance is 2 times 3 over 2 plus 3. And I get 6 on 5. And that is all. Now, when two things are in parallel and you find their total resistance, what you do is that you remove one of them, you totally remove one of them and put the answer on one. Let's say I've removed the 3 and put the answer on 1. Realize that when the things were in series, we put the answers together, then we remove one of them, we close it back and put the answer on 1. But when they are in parallel, you totally remove one and put the answer on 1. So something like this, I'll just do this and I will not draw. So I'm just putting the answer where the 2 is, so 6 or 5. And I will not draw the other part at all. So don't forget that when they are in parallel, you remove one and put the answer on 1. Don't close it back. Don't close it back. It's in series that we close it back. So let's see. If I have this circuit, and I want to know which ones are in parallel, what I'm going to do is 4 and 3. As I said, don't check the middle of the circuit because you will not find parallel. But let's see 3 and 6 going around, you will not find any other element. So they are in parallel. So I'll just do 3 times 6 over 3 plus 6, right? So now I get 2 ohms. So I will come and redraw the circuit and bring my 4 here. And these 2, I'm going to clean 1. So let me say I am cleaning the 6 and I'll put the answer on 1. So I'll totally clean this entire part of the circuit where the 6 is and put the answer on 1. Somebody too could have done the same thing like this. Where is 4? And he would rather clean the 3 and put the answer where the 6 is 2. and this circuit is the same as this circuit. Now realize that as I find some things in parallel, later we can all see that this 4 and 2 are in series. Go to part 1 of this video, you know what series is. So realize that we can be combining things in series and things in parallel together every time so that we can find something we call the total resistance. So the total resistance is when you put all the resistors within a circuit together, all the resistors within a circuit together. So realize that when I put these 3 and 6 together and I got 2, then later I realize that 2 and 4 are in series. So it means that the total resistance is 4 plus 2 because they are in series, and I get 6. So this is just the basic way to find total resistance within a circuit. First, you need to identify which ones are in series. Second, you need to identify which ones are in parallel. And you go step by step like that and put all the resistors together, and you'll be able to know your total resistance. Now, one thing I want you to know is we have learned two things: series or parallel. Now, one thing I want you to know is the fact that something is not in series doesn't mean it's in parallel, right? We looked at something like this. Now, most of the time, if you want to find total resistance, you have to check which ones are in series and which ones are in parallel. Now let's try to check whether 3 and 6 are in series. Realize that the current that passes through this 3 is not, when it gets to this junction, it splits. So 3 and 6 are not in series. But let's check whether they are in parallel. When I go around them, I don't see any other element. So 3 and 6 are in parallel. Now, realize that this time they were not in series, but they happen to be in parallel. Now, one thing I want you to know is the fact that they are not in series doesn't mean it will tend to become parallel. Let's see 4 and 6. 4 and 6, the current that passed through, when it gets here, it will split. So 4 and 6 are not in series. But let's check whether they are in parallel. If I go through 4 and 6, before I come back, I meet an element. So 4 and 6 are not in parallel. So I realize that it's not in series, it's not in parallel. So the fact that something is not in series doesn't mean it will become parallel. The fact that something is not in parallel doesn't mean it will become series. You need to use the criteria to check whether they are in series or they are in parallel. How do you know they are in series? The same current passes through them. How do you know they are in parallel? When you go around them, you don't meet any other elements. So thank you very much for following so much on how to know things in series, how to know things in parallel. In the next parts of this class, we are going to see how we can put things in series, things in parallel all together so that we'll be able to know the total resistance within the circuit. Thank you very much.